Okay, thank you for that intro. Those are a lot of words to say. So again, I'm Mike Miller. I'm here with Fujifilm Healthcare Americas, and I'm the Medical Informatics Director of Engineering. But I also oversee our cloud services business as well. So, of course, that's why I'm here in the AWS booth. They've given me a little bit of time here just to talk about a quick review of what we're doing with enterprise imaging and specifically on AWS. So just a brief background of who we are. So at Fujifilm Healthcare, we do enterprise imaging. So uh, that is our main focus in the healthcare industry and medical informatics. That is our mission. So radiology and cardiology, vendor neutral archives, advanced imaging with 3D, enterprise information systems, otherwise known as a RIS, right? We bring the entire imaging suite to healthcare. We've also been offering managed services since 2005, and now we call it managed cloud services, or you can also call it a SaaS. So we've been doing that for a long time. And over the past 3 or 4 years, we began partnering with AWS in order to improve our cloud services and our SaaS offerings to bring that scalability and security that we need for enterprise imaging in our industry. So I could spend all day talking about different topics in cloud and enterprise imaging, but today I want to focus on one area, and that is storage, because we have over 1,000 customers running Synapse packs in the United States. When you put together all of the other applications in our enterprise imaging suite, we have a lot more than that running imaging applications. And we talk to all those customers. I talk to them about infrastructure daily. I've been doing it for a long time. The number one value driver for cloud and infrastructure and problem to solve is storage, and it really isn't even close. Synapse Packs was initially released around the 1999 or 2000 timeframe. And so we have customers that have been acquiring data now for 15 to 20 years, and many of them have not deleted a single image. And so for a long time, we were working with customers on trying to manage ways to technically remove data, to do it legally. And in the end, they really decided not to delete data at all. So we're now looking at, instead of hundreds of terabytes of data, we have many large customers that are surpassing the petabyte scale for radiology imaging alone. And now, of course, with AI a part of our world, there's not a single AI vendor in this entire venue that will tell you to delete data, right? So the opposite behavior is going on now, where instead of trying to look at old data and how to remove it, it's all about how can we hang on to data. And so we're seeing the amount of storage in our industry growing exponentially. We also have Synapse Pathology. So digital pathology is a new entrant into our market recently. And what we're going to find with digital pathology is the scanning all of those historical glass slides of biological samples is going to generate data that's going to dwarf radiology. So for those of us that architect solutions and try and solve infrastructure problems in imaging, we're always looking for better ways to manage storage growth and manage cost. It's part of the challenge. It's the top challenge. And what we're going to find is that we have to bring tiering back into storage when it comes to medical imaging. So a long time ago in the early 2000s, for those of you that have been around for a while, there was a term called hierarchical storage management, HSM. And that was really common back then. So we would take data off storage arrays and we would dump it onto optical media like DVDs and big tape libraries and things like that. And then once drive manufacturers started developing drives that had these deep capacities, 10, 15, 20 terabyte hard drives, the need for HSM and tiering more or less went away. And so now we deploy these large disk arrays on premise, file or block storage arrays, large scale. They perform very well, easy to manage. But the problem now in the year 2023 and 2024, we're reaching a scale where that type of architecture just doesn't make sense anymore. And so we need tiering again. but we can't tier in the way we used to. We can't put data out onto slow media like DVDs. That just doesn't work for clinical environments and patient care these days. We need multiple tiers that can support extremely low latency storage for data that's hours old. We need to be able to support studies and images that are days, months, and decades old now. So we can do this now. If you have intelligent software combined with the storage services that the hyperscalers like AWS are now providing, now we're talking about real optimization. We're not just dumping data down to cheap media. Okay, so with our Synapse VNA, we have a feature, and it's really a core of our product called Image Lifecycle Management. And this is a feature that we've had since day one of the product, so it's nothing new. There's been various use cases over the years for lifecycle management of images, but now when you combine that core functionality with all of the different storage services that AWS provides, now we're talking about real optimization. So specifically, there's a concept I like to talk about called about data, and I call it clinically relevant attributes. Okay, so traditionally, when we talk about storage and we talk about data attributes, we're talking about file age, right? When was a file or a piece of data written? When was it last accessed? That's not enough to make decisions anymore. What we have to be able to do is make decisions on data based on clinical information. Is this an x-ray that's 20 years old? Is this a CT that was taken yesterday? Is the business entity that the VNA supports, is it a teleradiology type workflow where we're going to send in a CT study but maybe never read it again? Or are we supporting a workflow that is AI driven and may have several AI algorithms working against that data, where that data is going to be read many, many, many times versus in a teleradiology situation where that data is only read maybe once or twice. So once you take analytics about your data and you really understand the workflows about the businesses that you're supporting, now you can make decisions and you can leverage all of these storage tiers that AWS provides. Anything from extremely low latency file storage all the way into the S3, different S3 classes, including S3 Glacier Instant Retrieval, which is a service that it feels like was designed specifically for medical imaging, the way it works. But if you don't use it the right way and you don't understand and use data to drive your storage decisions, you're going to run into probably some cost issues that we hear about so often in the market. A couple other features of our VNA. We provide metadata queries for AI access. So a lot of AI algorithms have to read all of the data in a bucket in order to do its work. That is not an efficient or cost-effective way to access and read your data. You have to be able to access your data through metadata queries instead of paying for all the API transaction fees to list out a bucket that might have millions or perhaps billions of objects in it. And of course, your data is only as good as the access you provide. So if you're in our industry, of course, you have to provide DICOM access to your data. Everyone does that, of course, but we also provide access via DICOM web. So RESTful API access to data is a feature of VNA. And now that FHIR is finally gaining traction in our industry, we support FHIR access as well to data elements within the VNA. So beyond VNA, I just wanted to highlight that all of our products are cloud enabled. So we can bring an entire enterprise imaging suite and environment into cloud. And we've built our Synapse cloud on top of AWS in order to bring a much higher level of HIPAA compliancy than what we typically see on-prem. And the solutions that we put together in order to provide data protection for the PHI data that we're responsible for is much better than what I typically see with our customers on-prem. So we're in a really good position to leverage all the best-of-breed services within AWS to provide these services for our customers. So some success stories. Our products have been running in cloud for quite a while, so there are a lot of success stories amongst our customers out there. But there's one that we do like to talk about because of the. I like to talk about them because of the size and the scale. So New South Wales in Australia has an initiative called eHealth, and they provide imaging services to the entire state of New South Wales. And so our Synapse VNA acts as the core of that initiative. And so they have hundreds of hospitals that they're serving images out to, and multiple PACS systems across multiple vendors, multiple HISS systems, all connecting into Synapse VNA, now all running in AWS. And so this system was initially deployed on-prem years ago in a traditional manner, but in order to scale to the level that they're at now, which is around 45 million studies. By now, it's probably close to 50 million studies in that environment, adding 7, 8 million studies a year. In order to support that level of scale, they had to move into one of the hyperscalers. They chose AWS, and they've been there for a couple of years now, and they've been very successful in that environment. Here in the US, all of our SaaS customers, or all the customers where we manage cloud for them and their enterprise imaging applications, we deploy now on our instance in AWS. And so we've been able to show that our net new customers can be successfully deployed there. We've also been able to show that existing live imaging applications, our existing live Synapse customers, can be migrated into cloud and can be done non-disruptively. So that will be our model going forward. I know that was brief, very brief. It's all the time I have, but I just wanted to touch again on what we're doing here at Fujifilm Healthcare Enterprise Imaging. We can do all of this in the cloud, just touching on storage today, because again, storage is the top issue or the top challenge to address in our industry right now. So thank you.